metric time there? I don't know. Lunar seconds? Oh, hi. Anyways, greetings and welcome, friends. We've been talking about polar coordinates. Isn't it crazy that there's a one-to-one correlation between a rectangular coordinate system and the infinitely many points represented on it and the polar coordinate system, that every point has a corresponding point on the other measurement, so to speak. So anyways, here's question 19. We're on page 558, and we're talking about, can you graph this point? So I'm going to throw up this nice little polar grid coming at you, and here we go. The idea is the pole is at the origin, and like that. Then the polar axis is like where the positive x-axis would be. Angles are measured counterclockwise. You're all used to this. And so let's see. I want to plot the point 1/2 comma 3 pi over 4. The location of this point is known as r comma theta, is the order that they gave it to us. And r is somewhat the radius of the point, if you want to think about it that way. And theta is the angle or the direction to that point from the pole. So 3 pi over 4 is not a full pi radians, right? So pi would be here. Here's pi over 2. Here's pi over 4. 3 pi over 4 is like 135 degrees, or it's like 3 of these pi's over 4. So here's 1 pi over 4, 2 pi over 4, 3 pi over 4. You get the idea. So the location of this point is, I would go, oh, actually, no, that's a little bit on the nose there, but that's fine. So here's 3 pi over 4 radians. And now at this angle, I'm going to move out how many units? That would be 1, that would be 2 units. I want to move out half a unit, which happened to be conveniently right where I had started. So the point is just the point there. It wouldn't include the little line there or the arc. But that would be how I would represent the location of this point with a polar coordinate system. And that's the idea. You just look at an angle, go out that distance, or backwards that distance if that happened to be a negative number. So there we go. That's good stuff. 33, it said to graph the polar equation. So this is going to be the equation of all points, r's and thetas, that have theta equal to 5 pi over 4. Let's see, I wonder, should I grab another snapshot of this grid? Maybe I will. Let me get a little different numbers. And let's see, I'll make sure I'm right here. Bam! Here we are. Nice little polar grid coming at you. So theta is equal to 5 pi over 4. 5 pi over 4 is more than 4 pi over 4, which is equal to a single pi amount, right? So 5 pi over 4, if this is pi, I believe 5 pi over 4 is right here, if I'm not mistaken. So it's kind of a, what's that, 225 degrees, if you want to think about it that way. So I'm going to think about all points that have 5 pi over 4 as their theta. So for instance, 2 at 5 pi over 4 would be on that graph. 4 at 5 pi over 4 would be on it. 1 would be on it. Whatever this number is, 8 would be on it. -1 would be on it. -4 would be on it. And if I plot all of the points, 0 would be on it. It turns out to represent the line that passes through the pole, and all of those like so. So actually, I guess this line, could you guys give me a synonymous equation to this line? Theta equals what would be exactly the same line?
Pi over 4.
Theta at pi over 4 would have represented the same exact points, right? This versus that. It's still giving me all of the same points. So, or in fact, any plus or minus pi k's would give me a synonymous line or equation, so to speak. So there we go. There's that. I think my next one is over here where we were talking about the distance formula. And let's see, I've got 5s, and would this graph be helpful for me? I think it will. Yeah, it goes out as far as 5s. Let me plot these points for starters, just for funsies. You didn't have to. In fact, you could just straight up use the equation. It's essentially just the equation for law of cosines. Man, my mind went blank there. So pi over 6 radians, is this pi over 6, I believe? Right? You guys agree? Yeah. I think so. Pi over 6, 30 degrees. Or yeah, this is pi over 6, sorry, yeah. And then yeah, 60 degrees, and then, yeah, we're good. Because 90 divided by, yeah, yep. So here's my pi over 6. It's good to know what angle we're going at first. So 1 pi over 6 would be like this point right here at the pi over 6 angle and 1 unit away from the pole. And the other one is at 3 pi over 4, which we already talked about that angle over here. Oh, that's at my, I went a little far. 45 or 135 degree angle, and I'm going to go out 5 units from the pole. So that's like this right here. So here's where those 2 points are located, and I'm interested in the distance between them, like that. These are like classic Joker from like the very early Batman movies sort of thing, the nice purple-green combo. I like it. So here's my distance that I'm talking about, and if I want to think about the angles represented, here's the 3 pi over 4, here's the pi over 6. The angle in between, which I'll call, I don't know, alpha, is going to just be the difference of those two, which technically it wouldn't show up until I start doing the equation, something like that. It's going to end up being some sort of pi's over 24s. But let's actually just convert this to degrees for fun in that case. So 3 pi over 4 is 135 degrees, minus pi over 6 is 30 degrees. So it's 105 degrees is the angle between these 2 rays, so to speak. So what I'm going to do is just straight up use this little like law of cosines thing.
I thought that it was pi over 6 minus 3 pi over 4.
The distance, I believe, could work. Let's see.
I thought that was with the formula.
I guess I would it work in either case, I'm wondering.
Never mind. Sorry.
Well, did you get the right answer having a negative 105? Well, actually, let's think about it. Cosine of...
I couldn't take a cosine of a negative for some reason.
Oh, right.
I got it right anyway.
Well, cosine of 105, cosine's negative in this quadrant, and cosine of negative 105, cosine is also negative at a negative 105 degree angle. So it actually would have worked fine for us either way, because cosine's negative in both cases. Because cosine's positive here and negative here and there. So yeah, it actually would have worked out for cosine and negatives in those cases. So let's, oh really? I didn't have one more undo to get rid of that C? That's fine. That's fine. So my distance is equal to the square root of 1 squared plus 5 squared minus 2 times 1 times 5 times the cosine of the difference of these angles, even if you just plugged it in this way with parentheses or something like that, if you kept it in radians, that's fine. I'm going to do 105 degrees. I kind of like the idea of the pre-calculated out part, but it doesn't matter. Equals, and let me do this in portions anyway. So that's going to be 26 minus 10 times the cosine. Cos 105 is a negative value, as I'd anticipated, 2588, and then equals the square root of 26 minus 10 times that number. So it's the square root of 28.5882, and the distance is approximately the square root of that, which is 5.3468. So distance formula in polar form works, but it's completely related to just the law of cosines, whereas the distance formula in a rectangular coordinate system is really just a cousin of the Pythagorean theorem. So thanks for watching, friends. Have a great day. Bye-bye.